going to talk about how to do some calculations and talk about some of the expectations for the following, or the end of the week, going into next week. So we need to know the chemical equation. We've told you the compounds that we're going to be reacting with. What is the gas we're making? What's going to smother the fire? Because remember, it says on the first page. Carbon dioxide. Okay, so by looking at that, this is the initial part of my equation. I'm going to be taking hydrochloric acid. I'm going to be reacting it with sodium bicarbonate, and it's going to make CO2. We don't know the other two. It says common compounds, though. It makes extremely common compounds. The nice thing about chemistry is elements and compounds can neither be created nor destroyed. So there might be some hints in the fact that some elements have not even been produced yet, and you might reuse some other ones as well. So if you need some help with that, definitely we can go over it. I do want to address something before we go into this too far. Had a few questions. Well, my partner has already had class, and they did all this. Do I have to do anything? First off, I don't know how much more of a slacker question that can be. So maybe you should keep that one yourself. Secondly, what if we test you on this? What if we have a pop quiz halfway through and something even closely related to how we discovered the volume? If you don't have any idea how you did it, you're stuck. So it's really important that you're understanding where we're getting this all from. All right. Well, what's the point of all this? That's the key. The CO2. We want to fill the building with CO2. So potentially this is the size of the building. Okay? Well, if the entire building is going to fill up with carbon dioxide, then that's our container. And if that's our container, then that's our volume. So what we want is we want to have the volume of the CO2 equal the volume of the building. So if I know the building, I can figure out the volume. We're going to do that today. That would be the same as having the volume of the CO2. If the whole building is filled, then we're good to go. So I have a couple things here for you. Now, if you're doing the larger building, we'll talk about all that stuff in a little while, but that's going to change it a little bit. But the volume of the CO2 equals the volume of the building. All right, so how do I find the volume of this building? Ready? Yeah, length times width times height. I have 15, and I have 30, and I have 10. If you're using Dunder Mifflin, they're slightly different numbers. But I have length times width times height. And that's going to equal centimeters cubed. Why centimeters cubed? Because I took centimeters times centimeters times centimeters. So that's great. If you're doing Dunder Mifflin, I believe it's 30 by 30, and then we didn't tell you the height. It's going to be by 10. They're the same height. So you'll want to have that right away if you're going for the bigger one, which will actually be a little more fun because you can actually fit more things in and make it a little more clear. All right, once you get that, by the way, 1,000 centimeters equals 1 liter. So if you got 90 centimeters cubed, you divide that by 1,000, you're going to have 90 liters. That's not going to be the case, that's way too big. But just be mindful, about 22 liters, 22.4 liters is about this big. So it's going to be probably less than 20 liters, for sure. Okay, well, what's the point of that? If I can get a volume, now I'm getting somewhere. So if I have liters of this, and I want to find grams of this, and liters of this, you got to be careful. This is not a gas. That's a solution. This is a solid. That looks like stoichiometry. We have actually done most of this. And the parts that we haven't, I'm going to fill in the blanks for you. So if I go from here to here, let's say, you're like, oh, volume to gas. Great. I go from volume to moles, moles to moles, moles to grams. The problem is this first part, I'm not at STP. How do I know that? Well, because the P and the T on page 2, so if you open this up, we gave you all the pressures and the temperatures. We're doing it for the model. We're not in Norway or Venezuela right now. We have to make a model in Pulaski. Those are not 1 atm and 0 degrees Celsius. So what you do is you just look those up. This will be of the building, right there, and you can get moles. So what's the whole point? This is that detour. This is that jump that we get into the flow chart. What's the whole point of that? Is if I can get into moles now I'm in moles, I can go to moles of the other one, and then I can go up to grams. How many steps is that? It's 2 more on a T-chart. So what's going to look like when I'm all said and done, there's going to be 2 of them. I'm going to talk about the bottom one first, and if you want to just wait on writing, just kind of pay attention. I'm going to take the literal number of moles, so whatever it was, and I'm going to plug them into both. one. There I am, moles, mole ratio, do the grams, and I'm there. The other one is new. We have not learned it yet. It's about solutions. We haven't learned about solutions. Solutions, think of it like Kool-Aid. If I have a pitcher, a liter pitcher, and I put in some Kool-Aid mix, it's delicious. But if I put in a lot more of the whole container, it's ultra delicious. But I'm putting more in the same volume. That's what this is in this little yellow circle. We are using a thing called molarity. It's a fancy way of talking about a concentration. Take it for what it's worth for today. If I tell you it's 1.25 molarity, what that means is I have a certain amount of stuff dissolved in a certain amount of liquid. So it's 1.2, it's always moles over liters, 1.25 moles over 1 liter. If that was 3.75, it'd be 3.75 over 1. And I am telling you where to put it. You're not like, well, wait, what do I do with this? This is where it's going to be. Because there's going to be a mole here, the mole comes down, I'm looking for liters, I'm done. But where's the 22.4? That's for gases. This is an actual solution, like a liquid. There's a big difference. So this one's actually really short. If you're having some problems with that today, we'll help you out. When you're done, you're going to get some sort of a liter. Please understand you need to get that into milliliters. So if the ending is 0.35, that's 350 milliliters. You're like, that's so small. We're not rolling out 20-liter drums every time a new project comes out. Hey, next project, here you go, 20 liters of acid. Like that's not how big this is going to be. We're telling you you're bringing things like 2-liter bottles, not huge buckets. So that's how I figured that out. That's calculations that you will have to have done by Friday. We'll continue to help you today, and you'll get some time. I would write this down just for you to know. Ultimately, let me just bring this up for a second. Ultimately, you will have to make some calculations that aren't due for like 2.5 weeks. And you will have to tell them how much they're going to need for their actual building, not a model, their actual building in Norway, and their actual building in Venezuela. And it's not as much work. You've actually done the most work the first time. A lot of people would think, oh, okay, let me see how big the building and the model is. And you look and it says that the model is 1 to 100 scale. You cannot take these numbers here and just go times 100 times 100. It's not the way that works. The building's 100 times larger. So you have to literally take your length times your width times your height and multiply each of those dimensions by 100. Okay? And what that does is it gives you a new volume. And then I wrote here, I'll just read it once, and I have a typo. Plug volume back into PV equals nRT with new values, not lose, and repeat T-charts. Translation, guys, if you put in your new volume, just don't overwhelm yourself here. New volume, you put in the pressure and the temperature of Norway, or the pressure and the temperature of Venezuela, you get an N, you just plug in the N's, T-charts are exactly the same. That's all you have to do for like the bigger calculations. They're big. People are like, whoa, this is in like thousands and thousands and thousands of numbers. Yeah, you just did a card or a shoebox basically, and now you're talking about a building. It's going to take a little more, but we're not actually going to do that one as a model or as an example. You just need to tell them how much more they need. Okay, so later today, once I'm done, I only go for about half the time, I will leave this on the board. One of these screens will be there. So if you're having some problems, we can definitely help you with that, okay? All right, I'll come back to that later. What you need to understand for sure by Friday, there's a few things you have to have done and you need submitted, and it's worth points. So let's go through that. On Canvas, there is an assignment that's something along the lines of the fire suppression system. It's the only one in there right now. You need 1 page. I don't care what it is. It can just be on your notebook, and it's going to have everything that I'm saying right now. If you're going to do it on Notability, you can copy and paste and put things in there and draw it all right away. The reason why I say notebook, if you're not going to do Notability, it's going to be pretty hard to have a sketch that you're going to need in a minute. So what do you need? First, I get it. You and someone else might be partners. You need, well, we already filled out the form. Why do I need to write the name down again? It's just that much easier if we continually see who you're working with and we know. It's impossible to connect the dots. Well, they handed that one in here and they handed theirs here. I don't know who's with who. You both have to hand it in if you're working in groups. It's under your grade. So, well, we did one. It's great. Take the iPad, send it to the other person, and submit it as well. You need, be very clear on this, you need a sketch of a building reaction vessel, and piping. Illustrate idea where the acid and the solid will be located. You are not bound by this, but it can be a really rough sketch. Okay, so I got this building. I'm going to have a silo here. Maybe I have it here. Maybe I make a subterranean thing. Maybe I have 2 silos. I don't know. Okay, the piping, I'm going to have it run down the middle. No, maybe I'm going to do this octopus thing, and it's going to go on top. Maybe I'm going to have it on the bottom. You're not bound by it. You're not going to say, well, I drew that on Wednesday, and now I'm stuck. That's not the point. But you need to have something, okay? Now, you don't have to get to the point where it has to be finalized, and I'm going to talk about this right now. This is about as bare bones as it can be. Well, that's the door, I guess. Or, it could look like that. Now, what's funny is the more time people put into the external part, the slower usually they get because you forget about the main goal here. So this one actually, as great as it looks, and although like the inside's not really all that decorated, this wasn't all that fast, but it's really, really well done. I don't know what the heck they did with this, but it's all about the delivery. So just because the building doesn't look great, doesn't necessarily mean that it didn't go really fast. So there's different parts of that, but there is a definitely uniqueness to like theirs and how they did their piping, and I'm sure that they had the same thing if I was coming from the top. What we need you to start thinking about is that last part on there. Where are you going to put your acid and your solid? I don't care if it's not where you're going to end up with it. What are your thoughts? I'm going to have them separated. I'm going to have a cup. I'm going to have a trap door. I'm going to have something poured into something else. How are you going to do it? Get yourself starting to think about it. All right? What else needs to be on there? Okay, itemized lists of materials you need that you intend to use with estimated costs. I know you have a spreadsheet now. If you're using your iPad, you can just copy and paste and throw that part on there. Otherwise, you might have to write this out quickly. It's not the entire list. It's what you think you're going to use. Couple things with that in case you're confused. If you say you're going to bring in cardboard, if you're bringing it in, you write cardboard. You're using it. But what's the cost? You write 0. If you are going to bring it in yourself, you just write 0. And we've had this conversation already, but you're not bringing in your own acid. I want to know if you have your own acid. So that's how you're probably going to put that on that sheet as well. So you're going to have a picture. You're just going to say what you're all bringing in with an estimated cost. Okay, I was about to pull that down. That wouldn't work. And then the final thing on this sheet is you will need to have your T-charts of what I just showed you now, just 2. So an ideal gas cell with 2 T-charts. How much will you need? And it will be different if you're doing the large model or the small model. So that all needs to be submitted by Friday. You still have days to do this. It's not something that's all that stressful. Well, if you're sitting there going, oh, that's all I have to do, though, you do need to start moving forward. You should start building. You should start bringing things in. There's only so much time. May 8th is when we're lighting these up. There is no late ability, no late penalty, because there's no late score for not having a building. She's like, well, I didn't have it. I'm here now. Oh, none of us were here Monday. Then you better figure out a way to get it here, because we're not lighting them up after Monday the 8th. If one person's there, that's enough. Oh, they're at home. It's at their house. Then you better figure out a way to get it here. We're giving you 4 extra days to work on this than anybody else has ever worked on it before. So for a group to say we're not done yet does not register in my head. If that makes any sense. Like, you have more days than any other group has ever had. So to wait until the ending and then something not to go right, that's not acceptable. There are late penalties and allowances for the paperwork, but I would not do that. Hardly ever had a late penalty. The other 2 things by Friday, you need to create a copy of the invoice and journal. I will talk about that in a moment. The journal, I think, will be the single thing that you guys won't be able to do very well. Make an alarm on your iPad or your phone or something. Every day at a certain time, just have it pop up for the next 2 weeks. Journal. Today, type in your name. You put worked on calculations. To do next, bring in materials or start cutting box or building or measuring the dimensions, whatever you want to write. And that's all you got to do. You're in, you're out of the journal, and you have your entry at an appropriate time. Done. The other thing, if you haven't already done your partner form, that's all due by Friday. All right, so, of course, there's one wrinkle, and I made a mistake. If you're doing the smaller building, if you're doing the larger one, you're good. If you're going to do the smaller one, your budget has changed. because of that, this invoice sheet is not going to work very well. But Mr. Gussie, we already sent our link to you online. There's a new link. Oh my gosh. Right here, small building versus large. You click that one, it will have 185 and everything is appropriate with 185. What you need to do is just make a new copy and we will just hold tight. We will give you instructions. If you've not submitted your partner form yet, that's where you would link your address to it. Just go in here and make a new copy right now. And then you'll submit that as your actual address now. But that one will say 185. This one says 265. The big reason, it takes a lot more chemicals for the bigger one. And we're just checking it out. What's the bonus? That's what everybody wants to know. What's the bonus? First off, bonus is it's probably going to be a little more fun because you get to be more creative. You're like, all right, pass, next. It's not 10 to 20 to 30 extra points. It's only going to be a couple points because these are lab points. I'll say now, if I gave you 15 or 20 extra credit points for homework, those would still not be as much as like 2 extra credit points for lab. And you may not believe that, but that's just the math of it because of the fact that there's so few lab points and labs are worth so much more percentage-wise. So it's going to be around that range, about 2. And I know that doesn't sound like a lot, but whenever we give 1 or 2 even in a boost in a lab, it's amazing what the grade does all of a sudden. So it is a small boost, but it's also an appropriate lift. So if that changes your mind, like forget that then. We've never done it this large of a building before. We don't think it's going to really affect the difficulty all that much. So I don't think it's going to be a big deal. In all honesty, we're thinking this is probably where we're heading in the future. So that needs to be all done by Friday. And I wanted to end before I give you time. If I can find it. If I can find it. Nope. Nope. Okay, I'm not saying these are good. I'm not saying these are bad. I'm just saying these are models. What I need you to look at, though, you need to now look at this in a different light. You need to be looking at, okay, where do they have the solid and the liquid? If you can't figure it out, sorry, we're not going to stay looking at each one forever. And then look at the piping. Look at how maybe they're channeling the gas into each room. Again, some of these were probably not the best. Some of them might have been great. Just want to give you one last time some extra looks on what's going on. This one, it was coming up from below. That's just the inside. There wasn't much in there because they made the wall so darn thick. Same one. There's a cup. This one I like. There's a desk with a keyboard and a computer and a little mouse. I think they got a bucket. Whatever. There's a bunch of pipes. And some of you are like, I don't even know what I'm looking at. Saran wrap sitting on the top. Looks like a lot of piping, plexiglass. And some of them look the same. It's amazing during a year how many people mimic other groups, and not necessarily that they're good or bad. But this one they have 2. I'm not sure if they did. This group probably opened themselves up to $30,000 in OSHA fines because there's acid sitting right here and they're not wearing goggles. And that's actually the last picture. So, anyway, that is just giving you a little extra idea, nothing crazy or major. So what we are going to do is I'm going to leave up both of these screens. Okay? And your job is to start working on this. Now, the last thing, and I don't like standing out here, I don't like threats at all. It's just a reality. Because of the large amount of time that we're giving, as to help keep people going, this is why this thing's due by Friday, this initial stuff, is that If it continually becomes the answer, we see somebody not working, we're like, hey, where is it? Oh, it's at home. Oh, I already got that done. Eventually, we're going to ask, hey, show us what you have right now, what you've been saying, and all of a sudden, it is more likely than not, it's, I don't really have anything yet. Then that'll start dipping into your actual rubric of just miscellaneous non-participation. And we'll start losing letter grades really quickly. There's no reason that we can't get a decent grade on this. If you put effort and time into this, people usually come out with a minimum of a B just by chance, by just hard work and just by doing some things from time to time. There's been few groups that actually have done real hard work that have even struggled to get close to a B. But groups that are not following the rubric in the end are not just doing their kind of day-to-day, hey, let's start working on this. We need to continue working on the reaction vessel, or we need to start putting the pipes on. Like, keep focused on the building first. We will have moments, two more things. We'll have moments throughout these 2 weeks of us kind of coming back together, and we'll do a little, hey, today we're going to talk about how or why or how we're going to apply the diffusion of the halon system. How do we do that for your calculations? I talk about how you're going to format your invoice a little bit better, some things like that. Lastly, and probably most important, there will be a chance for you one time for 3 minutes to do a consultation coupon from us. And you get unlimited 3 minutes. It's got to be thoughtful. You can't be like, well, what's best? You tell us, how do I make this the best it can? It's got to be thoughtful. Like, we were thinking of doing this and this, but we're not sure if this or that would work. Okay, you have kind of thought through that a little bit. We'll answer that. You get up to 3 minutes. After that, it costs money to get like full-on advice. So kind of, if you have questions, you might want a place to be writing those so you can maximize that time. Cool.
You know those pictures that you just showed us, the examples, are those on the website?
No.
Are they on campus?
No.
Can we see them?
No.
Okay.
They were right here. Okay. So start working, please. Let me know what we can do for you. Today is the goal is to try to get as much of my Friday stuff as I can done.